All right, so today we're going to play detective. We're on the hunt for a hidden signal, a secret clue buried deep inside our most powerful AI models. And this clue, well, it might just solve one of the biggest, most expensive problems in all of tech today. And that brings us to our central mystery. Why is it so ridiculously expensive and inefficient to train these incredible AI? I mean, we're building models that can write code and reason like a person, but the way we're teaching them is just bafflingly wasteful. We're pouring fortunes into this, but are we doing it smart? The evidence says probably not. So, before we can even get to the solution, you've got to understand the sheer scale of the problem we're dealing with. And look, we're not talking about some minor inefficiency here. We're talking about a fundamental issue that's been holding back the entire field of AI. What does this number mean? 240. That's 240 GPU hours. Okay, to put that in perspective, that's like taking 16 of the most powerful AI chips on the planet, the H100s, and running them flat out for 15 hours straight. All that power, all that energy, and what does it get you? Well, not as much as you'd think. Yeah, you heard that right. All of that compute time gets you just 100 tiny little training steps on a big language model. And a full training run, that can be hundreds of thousands of steps. It's like trying to fill an Olympic-sized swimming pool with a teaspoon. It's insane. There has to be a better way. Now, of course, people have tried to solve this before. A common approach was to create a sort of curriculum, like you'd have in school. But these early attempts, they all had this one massive fundamental flaw. They were trying to be the teacher without ever listening to the student. See, the old way was to just pre-sort all the training data based on some external human idea of what's easy and what's hard. Start with the simple stuff, then move on. But the problem is, that completely ignores the model itself. The new insight, the crucial clue in our mystery, is that the AI is constantly sending out signals, telling us exactly what it's ready to learn. We just weren't listening. And this chart right here, it illustrates the problem perfectly. You've got two different AI models and a human rating for the exact same questions. And look at the results. They're all over the place. What's easy for one AI is hard for another. And what a human thinks is difficult might be a total piece of cake for the machine. So a single fixed curriculum, it just plain doesn't work. And this is the aha moment. This is where our detective story gets really interesting. Instead of forcing a curriculum on the AI from the outside, researchers at Duke and UC Berkeley decided to look for a signal coming from inside the model. And guess what? They found one. A clear, measurable signal that tells us exactly what the model is ready to learn next. They called it angle concentration. Now, that sounds a little technical, I know, but the core idea is actually super intuitive. Just picture the model's internal thoughts about a problem as a bunch of little arrows or vectors. Angle concentration is just a measure of how closely all those arrows are pointing in the same direction. So when the angle concentration is high, it means the model's internal thoughts are all aligned. The arrows are all pointing the same way. It's got a coherent understanding of the data. And when that happens, the learning update it makes, the gradient, is big and effective. It's like the student is focused and ready to absorb the lesson. But on the flip side, when that concentration is low, the model's thoughts are totally scattered. Those arrows are pointing everywhere. It's just confused. And trying to train it on that data, it leads to tiny, almost useless updates. It is a complete waste of time and energy. You're talking, but the student is absolutely not listening. So this is the whole thing. Right here, the researchers found that the model has a natural learning preference. Just like a person, it instinctively wants to tackle the problems it feels best equipped to understand first. It wants to learn that high concentration data before it even touches the more confusing low concentration stuff. We finally found our signal. Okay, so we have the signal, the smoking gun. What do we do with it? Well, now we can finally build a system that acts less like a rigid textbook and more like a really smart tutor. A system that gives the AI exactly what it needs to learn precisely when it needs it. And it all comes together in this thing called the GAIN-RL framework. And the process is just beautifully simple. First, you reorder all your training data based on that angle concentration score. Second, you start training by just sampling from the top of that list, all the high concentration stuff the model's already primed for. And third, and this is the really clever part, as the model gets smarter, you dynamically shift and start focusing on the harder, lower concentration data. It's a curriculum that's being tailored in real time by the AI for the AI. Okay, so the theory sounds great, right? It's really elegant. But the big question is always, does it actually work in the real world? Well, the answer is a resounding yes. The results from putting this thing to the test are, and I'm not exaggerating, pretty stunning. Across a whole bunch of different math and coding tasks, this new method achieved a training speedup of more than 2.5 times. Now, to put that in perspective, a process that used to take maybe 200 passes through the data now takes only 70 or 80. That is a game-changing leap in efficiency. But believe it or not, it gets even better. But here is the most mind-blowing result of all. This chart shows the GAIN-RL method, on the right, achieving better performance than the standard old-school method while using only half of the training data. I mean, just let that sink in for a second. By being smart about what data to focus on, the model learned more effectively from less information. It proves it's not about training harder, it's about training smarter. So, our detective story is solved. We started with this mystery of incredible waste. We found the hidden clue, that angle concentration, and we built a solution that just listens. The result is a massive speedup that proves sometimes less data really is more. And it leaves you with this really fascinating final thought, doesn't it? If we're only just now learning how to really listen to our AI, what other secrets are they waiting to teach us?